Hi, my name is Mick, and my proposal aims to jumpstart innovation in the construction industry. Over the last half a century, we have made great leaps forward in information technology, and yet we seem to stand still in other sectors of the economy. The smartphone in your pocket is over 100,000 times more powerful than the computer that landed humans on the moon. Such innovation drives growth through productivity gains and leads to higher wages and better living standards. However, this technological progress has not lived up to its transformative potential. Firstly, the returns from innovation are not equally distributed. Cambridge, the home of ARM and the UK's biotech capital, also ranks as its most unequal city. Secondly, despite the IT advancements, average productivity levels have been stagnating, and so have incomes. Thirdly, although consumers now enjoy cheaper software and electronics, we're stuck paying higher prices for almost every other category of good. I believe all three have the same root cause. We have failed to translate technological innovation into progress in industry. Nowhere is this gap more apparent than in the construction industry, where a lack of innovation has resulted in construction that is slow, expensive, polluting, and unsafe. Our buildings have gotten increasingly more complex. They now accommodate a whole series of structural and mechanical systems, and yet the way we build them has remained fundamentally unchanged. This becomes abundantly clear when we compare two buildings 500 years apart. Palladio's Rotonda has a monolithic, sculptural quality as a result of its brick and stone construction. Piano's New York Times building is much less sculpture, more an assembly of glass and steel. The two could not be further apart, and yet both were built with manual labor working on site. I believe it is this failure to adapt how we build to what we're building that is the root cause of the industry's inability to build fast, to do so cost effectively, and to shrink its ecological footprint. I propose to leverage the concentration of talent, capital, and technological know-how found in Cambridge to stage a competition that will jumpstart innovation in the construction sector. For the next decade, advances in materials, assembly, and fabrication will be tested through the design and construction of a series of experimental buildings along the River Cam. The goal will be to develop scalable construction techniques that can outperform traditional methods in speed, cost, and emissions. Together, the projects will form a dynamic exhibit of the state of innovation. As such, the competition aims to reignite the public's imagination for and confidence in the transformative potential of technological progress. I speculate that three competing visions will emerge as a result. The first will aim to use existing prefabrication technology to generate building elements that can be deployed in highly flexible ways. Here, a homeless shelter is built from a single habitation module. This cuts costs and time through standardization, but still allows for the creation of unique spaces via the interlocking geometry of the modules. The second will aim to bring the assembly line to the site in order to reap the benefits of speed and safety without trading off on the ability to build bespoke solutions. By leveraging advances in robotics, this timber observation tower rises from the ground in under a day. The third will aim to rethink the way we build altogether by taking cues from nature. Rather than assembling the building out of discrete parts, the vision will be to print it from a single material, a polymer the properties of which can be changed at the point of application. A material that has the potential to be stiff and structural in one configuration, porous and insulating in another, light and transparent in yet another. As such, this has the potential to change the way we think about buildings altogether. I speculate that the first implementation of such a technology will attempt to grow the skin of a building on top of a conventional frame structure. As a result of 10 years of such an experiment, we hope to breed out technologies that are ready for the mass market. The goal is to develop the tools we need to build our future.